that you are here. Thanks, Ikra. Or you can open your camera and let us see your face, and that would be even better.
Be crazy. Mr. Tyson.
Hi, Mr. Tyson. Thanks for letting us see your face. All right, I see about half of us are back. If you haven't yet, type something in the chat so we know you're with us, or open your camera and let us see your smiling face. Thanks, Alex.
Nice to see your hair. Tu pelo es muy bonita.
All right, it looks like most of us are back and ready, so we are going to get started. Remember, at the very beginning today, we asked you to have a few things out in front of you. You needed your note packet and something to write with, something with a couple different colors. So if you don't have the colored pencils that you got on that last day we were in class, just grab like a pencil and a pen, or a couple different colors of pens so that you have just a few colors. And then you need a piece of paper. We're going to go through and do the one-pager together, just like we did for Unit B, and then you're going to have a chance to submit it right away before we even start the test, okay? Remember, the one-pager is quite a few points, more than even some of your practice work, so this will be a good thing to get in at the end of the trimester. All we have left now is this one-pager and the test.
Oh, I'm getting there.
So we're going to go through really quick just to remind ourselves why we do this. And this is the same slide we went through last time, so we can cruise through it. Remember, we do this because it can help you on your test, and it helps you organize your notes. I know there are quite a few of you who didn't have your note packet, and you've been just kind of writing things on your own as we go, or not writing them at all. And so this is something you can use while you take your test today that can really, really help you, okay? So it's gonna help you take your notes and put them into ideas that make sense to you, not just to Miss Morale or myself. Also, writing helps us remember things. And so even just by writing it down, when you get to that test, it's gonna make it a lot quicker and easier for you to remember what you need to remember. All right, so our first step is to plan what we're gonna put on our one-pager. So we're gonna look through our Unit C notes. We're gonna find how many lessons there were or how many big ideas we covered, okay? So again, this one we had 4.
Oh,
You can put this around.
got it.
So we did graphing, substitution, and then we did that elimination with add and subtract and multiply. So we're gonna kind of group, I think we can group those last two together, the multiplication and the addition and subtraction, but graphing and substitution are really different from the other two. So we'll maybe do ours instead of 4 sections this time, maybe 3 sections. Does that make sense, or would you like to do something different, period 1?
I'm thinking in that first section, we might want to break it up into when we do like the solutions, like is it a solution, and then the graphing. So we might kind of want like 1A, 1B, and then 2, 3.
That sounds great. Okay, so let's look at then, we kind of have a little plan. Right now, Miss Morel and I are telling you what your plan is, but if you disagree, open that microphone and let us know, and we would love to hear your opinion, okay? After that, you're going to choose how you want to organize, which we did just kind of talk about, where Miss Morel said that it might make sense for that top one to kind of be in 2 separate boxes, and then to fill in information for the rest. Remember, when you do your own one-pager, so like maybe starting in Unit D, you can decide if you'd rather do more like an outline or more pictures, just depending on how you think best and how your brain works, okay? For right now, everyone's doing it on paper, but moving forward, you'll be able to choose digital or paper, okay? All right, let's go to the next part. These are kind of our big ideas. And I just pulled these from the notes, okay? So Miss Morel and I went through the notes, and we kind of thought what were the big things that we need period 1 to remember. and this is what we chose. If you think there's more, you can always add more to your notes. Or if you feel like there's something here that you really already know without even writing it down, you might choose not to write that part down. Okay, but kind of the big concepts were systems of equations, solutions, and then choosing which method to use. Should we use a graph? Should we use elimination? What method should we use to find out if we have a system? And then the big vocabulary words were substitution, elimination, common multiples, graphing, ordered pairs, and that word column that we used a lot. And we'll talk about that if you don't remember, but column just means when we are adding or subtracting and we're lining those equations up on top of each other, the column is the section that is right on top of the other one. So each one of those terms is in a column.
I'm working on it. Sorry.
All right, then remember when we're done, we'll add any little extras we want to help us. So this could be pictures. You could translate to another language. You could add extra examples or details that you want, okay? All right, we've seen some of these examples before, but just to remind you, these are some different options for what they could look like. You can go through pretty fast, Ms. Morale, because we've seen these. Some of the awesome ones that your classmates have done.
That's it.
That's it. Okay, so we're going to get started. So we kind of said we wanted to have 3 big sections, and then that top section with graphing sort of split into 2. So what if on your page we just draw like 2 horizontal lines, and we split our page into 3 sections, and then that top one will cut in half vertically. And if we need a little more space, we can make that one a little bigger too, because graphing takes up a lot.
And remember, you can be doing this on the last page of your notes, like on the very back side of the notes on that page 40. There's a blank spot there, so if you want to do it on your notes, you can. Or you can be doing this on a separate sheet of paper altogether. That is up to you. So I'm going to do my 3 here, and then I'm going to kind of do that dotted line because it was part of the first lesson. And I'm going to just, whoops, I did not want to do that. I'm sorry. 1 second. I don't know what's happening. All right. I don't know. I'm going to do a dotted line for this first one to kind of just show. And I'm going to give it a little bit more space for the graphing because that's going to take up a little bit more space than when we do the solutions. In fact, I might move it a little bit over.
All right, so set up your page and then have your notes ready. We're going to go through our notes and kind of write information as we need. We probably won't use quite as many different colors as we did last time, just because we won't have quite so many different parts as we did on Unit B. So if you just have a few different colors, you should be fine. So our first set of notes is about graphing systems of equations. So the really big idea we want to add for graphing is that idea of a solution. So that's going to be the first thing we talk about. And who can remember, what should our solution look like? When we're done with our problem, what does our answer look like?
An ordered pair.
Very good. So we're going to write an ordered pair. And remember, our ordered pair has our x and our y. So when we did like our Alex practice in class, it would have like x equals blah, 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 y equals blah, blah, blah. On your test, you might have somewhere you put it like that. Otherwise, try to write that answer as that ordered pair, that x and that y, okay? So that's what your solution should look like when you're finished.
All right, and then, sorry.
No, go.
Oh, I was just going to start going over what it's like to have if it is a solution. So if you're given, this is kind of an example, so I'm going to switch my colors to green here, and I'm going to just put EX for example. That way I know that this is a good example here. So if we had the ordered pair, -4, -1. And I want to know, is it a solution to 6x plus 3y equals -12? And I want to know, is it a solution to that y equals 3x plus 11? And this is just an example I'm coming up with. We could use an example from our notes. I just was able to kind of come up with a few extras so that way we can use it with your notes. So if we have an ordered pair and we want to know if it's a solution to both of these equations, it has to work for both. Okay. So what we're going to do is we're going to put in our x and our y. So remember, this is our x, this is our y. And we're going to plug them in and see, do they work? So we're going to do 6 times -4, because that's our x. And that says plus 3y. So we're going to say plus 3, and then times our y, so -1. So this is like our plug it in, plug it in. Remember when we watched that commercial yesterday? It was a good time. And then we would figure out what is 6 times -4 plus 3 times -1. And we would probably use our Desmos calculator for that, which I don't have pulled up. I should probably pull that up. Un momento. There we go.
Some of you who are faster than Desmos, if you know those answers, go ahead and tell us. What is 6 times -4?
-24.
Awesome. And then what is 3 times -1?
-3.
Okay, so we've got -24 plus -3
-27.
equals 12. Yeah, does that equal 12? Does -27 equal -12? No. So even before we look at the next one, could this be a solution?
In order for it to be a solution, what has to be true?
Both equations.
Both equations. Very good. So at this point, if this were like a problem on your test, you could stop. You don't even have to do the next one. If you don't really trust yourself and you wanted to do the next one and just like make sure, you could. But it's possible that you would have one no, one yes, and then your answer would still be no. It's not a solution.
Or with how it's set up, you might want to do both. The way that we decided to have it set up, we do want to have you plug it into both still. But in the end, you know that answer is going to be no. Right?
Should we go through that last one just to finish it out?
We should, I think.
Okay.
It's kind of what the test looks like.
Okay, good.
So when we plug this in our calculator, we can just type in that whole 3 times -4.
And that's a yes. But look back at our big note that we wrote in red. It has to work for both. So on your test, would you say yes or no? Is this a solution? If we have one yes and one no, is that a solution? No. Good. Because remember, it has to work for both.
Awesome.
All right, so let's look over at this next section about graphing. Remember, you have page 30 in your notes. We're not going to copy that whole big chart down, and you shouldn't need to label any graphs on your test with that consistent or inconsistent, but there still are some really important things about graphing that we should look at. So we're going to go through a little example of how we would graph a system to find a solution. So we're just going to do our best to draw out a graph. It's not going to be perfect, and that's okay. If you have lines on your paper, you can probably even do it better than we'll be able to do on here. So can anyone remember when we want to graph a point, what do we want our formula to look like? Or what do we need our equation to look like? Good, so we need an X and a Y. So we could maybe have an ordered pair. And if we had an ordered pair, then we could graph that point right there. But what if I want a line?
A slope and a y-intercept.
Good, so we need that y equals mx plus b, right? We need to know the y-intercept and the slope. So if you're given a problem that's not in this formula, you'll have to switch it so you have it in y equals mx plus b. And when we have y equals mx plus b, so we have an example like...
Do you want me to just do the example?
Yeah.
Okay. So we have y equals 5 over 2x minus 3.
Okay. So where is our m?
Which one of those numbers is the m?
Good. Remember, m stands for slope, so that's that 5 over 2. And where is our b? So remember, our equation is y equals, we already have the y, we already have the m. Good. So that, that y-intercept would be the -3. That's our b. And remember, when we graph, we're going to start at that y-intercept. Okay, so when we have an equation in y equals mx plus b, we start at the b. So from that origin in the middle, we're going to go to -3 on that y-intercept. And that's our first point. Then from there, we're going to rise and run from our slope. So is that slope positive or negative? Is our slope positive or negative? That 5 over 2, is that positive or negative? So our y-intercept, that -3 is negative. What about our slope, our m? Good. So picture that line in your mind now before you even draw it. A positive line, remember, will be going up on our graph. Okay, when we move left to right, that line will be moving up. So we're going to start at that purple dot at -3, and we're going to rise 5 and run 2. And there is our second point. So that is one line. Okay, so now we can draw our best line between those. All right, and then we need one more equation in y equals mx plus b.
So y equals negative x plus 4.
Okay, so right away, let's get started here. Let's start with our b. What's our b on this equation? Y equals negative x plus 4. What is the y-intercept?
Freaking out, sorry.
Totally freaking out. And what is our slope? When it just says negative x, what is our slope? So think about this. Good, Abdisalan. And if I wanted to write it as a fraction, what would I write? Awesome. So it would be that negative 1 over 1 would be our slope. Because remember, when we have a variable all by itself, we can always sneak that 1 in there because we have at least one of them. Okay, so we're going to start with our y-intercept. So start at the origin and go up 4. That's our first point. And now we're going to rise and run according to our slope. So is this slope going to be positive or negative? It says negative x. So is that positive or negative?
Negative.
Good. Be moving in the negative direction. Down 1, over 1. All right, then we're going to draw our line.
And what's going to be really nice on your test, and that'll make it a little bit easier to work with.
So when we're graphing, our solution is that ordered pair that they cross. Okay, so the ordered pair, x and y, where these two lines cross, will be our solution. So it's kind of hard to read because we just made this graph on our paper, but can anyone tell me what is our solution going to be here? What's our x? What's our y? Two, 2. Yep, very good. So your answer, your solution, would be 2, 2.
Right?
Awesome.
So, up 2.
All right, period 1. Any questions about this before we move on to the next section? Now's your time. If there's something that still feels really confusing or that you want to go over again, now's the time to do it. Okay, then let's move on to substitution. Remember, that's a little out of order in your notes. That's actually page 35. And the big idea for substitution is what that word means, substitute. So what does it mean to substitute something?
Remember we talked about like soccer when you sub out a player? Or volleyball?
Switch, whatever word you want to use. Write it in French or Spanish, whatever you want. What this means is that we're usually given one part of our answer. We're given something we need, and then we have to use that to solve the rest. So we either need to know a y or an x that we're then going to replace or switch out in the equation to get both our x equals and our y equals. So when we're done, we're going to need our answers to look like x equals, y equals.
I don't know what I'm writing there. Should I write that? No. And green again. So if we had negative 5x minus 2y equals 5. That was one equation. And then we had another equation, y equals 4x minus 9. Okay, so we have that y equals. And so we're going to take that and we're going to replace that y. So I'm going to write in purple, I guess, for the steps. So
If so far you've been sitting there playing video games and ignoring us and thinking you don't need to worry about this, if you write down nothing else, write down this part, because on your test, remember, we're going to ask you to justify. We're going to ask you to tell your steps. So we're going to walk through this right now and show you exactly how you'll need to do that on your test. Okay?
So in that first equation, it said negative 5x minus 2y equals 5. So what we did there is, or my next step. I was going to solve this equation. What would I do next?
Thank you, Ikran. Combine like terms. So what are our like terms? Good, the ones with those x's. So we have negative 5x minus negative 8x. And if you want to use Desmos when you're working with those negatives, go ahead and do it. That can get kind of... We're going to undo that 18 by subtracting 18 from both sides. So we have negative 13x equals negative 13. We still need to get x by itself because we want our answer to be x equals. We have to solve. Yeah, it's getting wonky again. So we'll have a negative divided by a negative is a positive, so x equals 1. All right, are we done? Why not? Look back at the top. What do we need our solution to look like? Good. We still need that y, because we need x and y. Awesome. So now we're going to use substitution again. We're going to take the next equation, and we're going to substitute that x. Instead, we're going to use the y. So 4 times 1 gives us 4. So we have y equals 4 minus 9.
And this one's really nice.
Awesome. Anything you want to ask or add or talk about with substitution?
So in this example, it started with a y equals. If it started with an x equals, you would just kind of flip that idea of where x and y are. So instead of replacing the y, you would replace the x. And then solve for y. And then you'd replace the y, solve for x.
All right, let's go to the last section, elimination using multiplication, add, and subtract.
Can I just write elimination? 37. So I like to have those page numbers there because remember, if I don't get enough information when I'm taking my test from this one pager, we could go back into our notes and we could find where that is. All right, what does eliminate mean? What does that word eliminate mean? Talked about it the last week.
Move, you can say get rid of. delete, whatever you want to say. So we're going to use the green for the example and the purple for our steps again, just like we did with substitution.
And then our second equation is going to be 8x plus 5y equals 4. So our first step here is we're going to decide, do we want to get rid of the x? We want those coefficients to be identical or the same. We don't have that right now. So this time we get to choose, do we want to get rid of the x or do we want to get rid of the y?
There's no wrong answer, so someone can choose. What do you think? All right, Ikram says x. Ooh, good. Aisha does too. Okay, so if we want to remove the x's, and I'm going to give you a big clue, we're going to use multiplication to do that. What do we need to do? We have a 5x and we have an 8x. What are we trying to find?
Common equals.
Good. So you can go through like how we did yesterday with our first example and kind of list it out 5, 10, 15, 20, 25.
And so then once we figure out what we're going to multiply those by, we just multiply the whole equation by that. So we can write times 5 times 5.
All right, so now let's rewrite those. So 5 times 8. Put it in your calculator if you need to, otherwise 5 times 8 gives us 40. So 40x minus 3 times 8 gives us 24. 24y equals 4 times 5 gives us 20. Okay, so now what can we do next? What would our next purple step be? What are we going to write here? What can we do next?
4? 4? I think 4, but I don't know.
What does our answer have to look like? Okay. So I would probably pick that 8x.
Sorry, my smartboard's getting a little frustrating, so I'm just kind of working.
Yeah, just
Plus 20 equals 4. Divide by 8. And we get x equals negative 2.
all right. Anything else you think we need about elimination right on here?
So something to remember is if you don't need to multiply, if you already have a coefficient that's the same, let's say we started with this negative 40 and 40, you can just jump straight to this add or subtract. This multiply is only for when none of them line up together.
All right, we're going to give you about 4 minutes on the clock to take a picture of your one-pager and submit it into the assignment in Schoology, okay? So about 4 minutes, and then we're going to go through the test a little bit before you start. So everybody take a picture, pop over to Schoology, and submit your assignment right now.